Okay, this is lesson 23, graphing relationships. So we're continuing from yesterday. We're looking at, kind of like the slide or the swinging video. We're seeing what's happening. We have a relationship. Time is passing. What's happening with whatever the other variables have, whatever's happening with the other variable. Okay, so the objective. Let's all read the objective nice and loud. Ready and begin. I will be able to describe a graph and its description. Okay, good. Okay, good. That was a lot neater than second period. So,
thank you.
First or second, yeah, you guys did well. Okay, good. So we're gonna be looking at that. So we're gonna be thinking about stories, right? So we were watching those videos. Those videos were actually stories. The first video was about a girl swinging from a tree, and there was a story, and we related that to a graph. Okay. Or today we looked at the person sliding. We're like, oh, what's exactly happening to the person's waist when they're sliding? Okay. But today we're actually gonna read the story. So it's the same thing as watching a video, except you're reading and you have to imagine what's going on. So it's a little bit harder. So, and that's one of your standards, right? Is we have to be able to contextualize, decontextualize information, which means like we have to take a story and make it into math, and take math and make it into a story. Okay? Here we go. So, sorry about that. Here we go. So, I'm going to show you an example. Usually I show you two examples, but today I want to just show you one, okay? So, I'm going to read the story up here. And then I'm going to read it again, and I'm going to show you how I would do this, okay? So you don't have to write anything down right now. Just watch up here, okay? So let's all focus on this story right here. Okay. Oh, sorry. Okay. Here we go. At the start of a snowstorm, it snowed 2 inches an hour for 2 hours. Then slowed to 1 inch an hour for an additional hour before stopping. 3 hours after the snow stopped, it began to melt at 1/2 an inch an hour for 2 hours. Okay, so I'm thinking, oh, it's a snowstorm. There's the beginning, there's no snow, and then all of a sudden there's snow on the ground. There's different rates, and then it starts melting. Okay, cool. So I'm thinking about snow. That's what I'm thinking, okay? So I'm going to read this again because as a student I want to make sure I got it right. So I'm going to read it one more time. At the start of a snowstorm, it snowed 2 inches an hour for 2 hours. Then slowed to 1 inch an hour for an additional hour before stopping. Okay, so I'm getting some data here. I'm noticing it's snowed for 2 inches an hour. So I'm going to color this in red, or I'm sorry, orange. And then I see this other one. Then it slowed to 1 inch an hour for an additional hour. So I'm going to write this. I'm just going to highlight this in blue. Before stopping. So I'm going to just kind of like put a little note here. It stopped. Okay, that's good to know. And then it said 3 hours after the snow stopped, it began to melt. Okay, so I know it still stopped here for 3 hours, and then it began to melt at 1/2 an inch an hour for 2 hours. Okay, so I have some data here. I know there's a lot of colors up here, but it gives us an idea of what's going on. Okay, so here's my story. I'm going to erase some of this so it gets off my graph, okay? So I just focused on my story, and I'm kind of figuring out, like, what's going on. So I know, like, from my stories, what's always moving forward, that I can't ever reverse time, right? So time is always moving forward. So I'm going to make this x-axis time, okay? And I notice that we're talking in hours, and it's in whole hours, okay? And then I notice that this is about snow, and I'm noticing, okay, if I imagine it before a snowstorm, is there any snow on the ground? No, not necessarily, right? So I'm just going to put the total snow, and it's in inches because that's what they're talking about in this story. And I'm noticing that it's not very many inches. It's like 1 or 2 inches. So I'm just going to go from 1 to 10, okay? So now I have to think back, and I'm going to go focus on the colors that I talked about, the keywords that I had, okay? So the keywords that I had, so it said the start of a snowstorm, so that means when it starts, there's no snow, right? So I know when it starts, there is going to be no snow. So I'm going to put a point at 0 hours, right? Because there's no snow when the storm starts, okay? And then it starts to fall. I know that snow doesn't just appear like, ding, there's snow everywhere. Is that how it works in real life? No, it's got to continuously move. So looking at this orange line, 2 inches, it snowed for 2 inches an hour for 2 hours. That means after 1 hour, I think, how much snow should there be on the floor after 1 hour if it's 2 inches an hour?
2 inches.
2 inches, right? So I'm going to put a point there. And then I think again, if it's 2 inches in 1 hour, how many inches should be on the floor after 2 hours? 4 inches, right? So I'm going to go to 2 inches and then go up to 4 and plot a point. Okay, then I go to the next part of the story. It's in the blue, what's underlined in blue. It says, then it slowed to 1 inch an hour for an additional hour. That means it went 1 more inch after 1 more hour. So at hour 3, I should get 1 more inch. So since it's 4, I'm going to add 1 more to 5. Okay, and then it said that it stopped. So it stopped snowing. That means it shouldn't go up or down because I know it's not melting yet. And it says it's for 3 hours after the snow stopped, right? It began to melt. So that means it's not snowing and it's not melting. But after 3 hours, 1, 2, 3, it starts to melt. And it says it melts. The purple line, there you see it melts at 1/2 an inch for 2 hours. So that means for the next 2 hours, it's only going to go 1/2 an inch. So it's going to go 1/2 an inch. Oh, sorry. After 1 hour, it's going to go down 1/2 an inch, and after another half hour, it's going to go down 1/2 an inch. And that's it. That's all the information I'm getting. Okay? So I just graphed the story. Then I think to myself, well, we'll just leave it like that for now. I think that's good. Okay? So again, what did I do? Here are the steps. I read the question carefully. I read it twice. I identified keywords to describe the relationship given a graph. So I have my colors here I'm using. You could use whatever you like to identify stuff. Okay. Then step 3, respond to the question by using complete sentences. I don't have any question here, but I wanted to graph it, and then I'm going to label it as continuous or discrete. So, all right. So what I like to do is have you kids talk about how I did this. So since it's Wednesday, let's start with 4s today. 4s are talking about how did I graph this, okay? Explain how I did the labels and everything. Ready, set, go. Think about the story with the snow, and now turn to your group and tell them, is it continuous or discrete? Be very careful. Just on this example, continuous or discrete? Okay, kids, what do you think? Continuous or discrete? Raise your hand if you say it's continuous. Raise your hand if you say snow falls discretely. It's just like boom, there's all of a sudden snow and it disappears. Okay, good. So if it's continuous, what should my graph be? Should it be points? What should it be? A line. So we should connect the dots here. So I'm going to connect the dots. We love connecting the dots. And that's it, right? Because this makes sense, right? Eyes up here. In 1 hour, we got 2 inches, right? So what about in half hour? How many inches should I have in half hour? Just 1, you see? Is it possible to... What about in 15 minutes? How many inches should I have? Maybe a 1/4 inch, right? Does that make sense? So is it possible to go in between hours, like to specific minutes? Yeah, because it's continuous. You see that? You got it? Yes. Okay, cool. So what I'd like you to do now, I'd like you to just draw the graph, okay? And label the graph. Let's call this graph the snow example. That's all you got to do. Snow example, all right? That's all you got to do. I don't want you to write anything else down. I'll even highlight the part that I want you to write because there's a lot of writing in here. Snow example. That's all I need you to do, okay? I can give you about 2 minutes to write out this graph, okay? So that's the first example. So I did that one. Let's work on one together, okay? What's going on here? Oh, there's one more thing I want to talk to you about, and this is called domain and range, okay? So we know it's continuous, okay? So I want part of your answer, you'd have to write that. We know that, okay? The next is domain and range. Raise your hand if you remember a teacher once upon a time talked to you about domain and range, okay? Okay, domain and range. So domain, this is not very hard. You just have to think about it in 2 terms. Domain is how far to the left and right does the x go, okay? So how far does time go to the left, everyone? Where does it start on the left? 0. So then we would write d colon 0. And then how far to the right does it go? 8. Do you see that? 8 hours, you see? So then we put 8 here. Just watch what I'm doing so you understand how to do it. Then you put x in the middle because it's the x-axis, and you put less than or equal to here, and less than or equal to here. And what that's saying is that time, which is x, is going to be greater than or equal to 0, but it's also going to be less than or equal to 8. Okay? Does that make sense? So again, domain is how far to the left and right does the graph go. You see how the graph goes from here all the way to here? It starts at 0 hours and it goes all the way to 8 hours. You see that? Okay? Thumbs up if that makes sense. Thumbs down if it still doesn't make sense. Okay, that's all we're doing is identifying how far and up or left and right does it go. Range now. If domain is how far to the left and right, what do you think the range is? Good, so range is how far up and down. So then to write the range, this is how you do it. Where does the graph start on the bottom? What's the lowest point on the bottom? 0, right? And the range is the y-axis, you see, so it's like how many total inches. So what's the smallest amount of inches again? 0. What's the largest amount of inches does the graph get up to? Does this graph reach all the way to 10? No, so how high does the graph go? 5. So then we go 0, 5. Put a y in the middle this time, and you put the less than or equal to sign, less than or equal to sign. Oh, sorry. Okay? That's telling me that the graph, or the inches, will go from at least 0 all the way up to 5. Okay, so let's have, I know we don't have everyone here, but let's have 3s tell the group about domain, and 2s tell the group about range. If there is no 3 or 2, someone else volunteer. Ready, set, go. Here we go. Now let's talk about the salesman here. So we're going to do this together, okay? So I'm going to read this out loud. Just follow along. Here we go. So we have a local salesman who's going door to door to sell vacuums, okay? For every vacuum he sells, he makes $20. He could sell a maximum of 10 vacuums a day, okay? Damien? Okay, one more time. Listen to the story. A local salesman is going door to door to sell vacuums. For every vacuum he sells, he makes $20. He could sell a maximum of 10 vacuums a day. Okay. So what are the two things we're talking about here? Talk to your group. What are the two things we want to have on our x and y axis? Go.
The x-axis, we want to have.
And remember, the x-axis is kind of like what predicts the other thing. So like the x-axis drives the other.
The x-axis will drive the other, like, vacuums, right? That makes sense.
Okay, so x-axis, what do you think is supposed to go on the x-axis? The what? Is there time on this one? No, so what are the two things that are happening in the story?
Vacuums and money.
Vacuums sold and money. So do you have to sell vacuums in order for you to get money, or do you get money and then sell vacuum? Good. So what should be in the x-axis?
Vacuums.
Vacuums. Good. So let's all start writing this together. Doing this one together. Okay. So we have we're going to put on the x-axis. We're going to put amount of vacuums. Okay. So how many total vacuums can this person sell a day? 10, right? So we're going to just write the numbers 1 through 10, right? Going by ones. All right, so we're all doing this in our notes. We're all doing this in our notes. We're all doing this in our notes, writing down the graph, numbers 1 through 10. Continuing, so what's going to be in the y-axis now?
The amount of money you make.
Good, the amount of money you make. So now turn to your neighbors and tell them, like, what should you go by? And why? Okay, so kids, what do you think? Are we going to go by ones? Like $1, $2, $3? What should we go? 20s, right? Because if he sells one vacuum, how much money does he get? 20 bucks. So let's go by 20. So we got 20, 40, 60, 80, 100, 120. It's like he gets a $20 bill for everything, for every vacuum he sells. Okay? Does that make sense?
Yeah.
Awesome. So now I want you to work with your group. I want you to graph what happens when he sells one vacuum, 2 vacuums. How much money will he have? 3, all the way up to 10, right? Because the max he could sell a day is 10. Ready, set, go. You're graphing with your group. If he sells 1 vacuum class, how much money should he have? 20. So you should have a point there, right? What happens if he sells no vacuums? How much money should he have? 0. So we should have a point down there, right? What happens if he sells 2 vacuums? 40. What happens if he sells 3 vacuums? Good, right? And we keep riding this all the way up, right? Good. So turn your neighbors, look at theirs, and give me a thumbs up if theirs looks like mine. If not, then give me a thumbs down. Okay, should we draw a line through this?
Yeah.
Did I draw a line on this? No, so not yet. We don't want to do that yet. Okay, now we have to think about the story. Okay, think about the shower, right? Water flows continuously in the shower and flows continuously out. Snow falls continuously and falls continuously out, right? Think about this example. Continuous or discrete? Talk to your group. Go. And tell your group why is it continuous or discrete. All right, kids, so what do you think? Continuous or discrete? Raise your hand if you say it's continuous, like you're continuously selling more and more vacuums. Raise your hand if you say it's discrete. Wow, everyone, why discrete? Let's see, one person. Oh, Marianne, why? Is that why? Do you agree with her? No? What? Okay, let's get some other answers. Yeah, right here in the front, right here. Babino.
Because he could sell more than one vacuum at a house.
Shh. You could sell more than 1 vacuum at a house? Is that true? Let's think about, let's think about the water. Let's think about snow. Does it just appear automatically? Yep.
Well, you don't know how many vacuums you sell a day. It might be like different numbers.
Okay, that could be the case. Yep.
There are people like just lined up ready like to sell. You can sell a vacuum in one place and then go to a different place and sell another vacuum.
Okay, we're almost there. We're getting there. Look at this last example here. With the rainfall. Eyes up here, please. Rainfall. In 1 hour, how many inches have fallen? 2. In 2 hours, how many inches have fallen?
4.
Good. In half an hour, how many inches have fallen? 1, right? Does that make sense? Do we have to wait a whole hour just to see 2 inches, or are we going to just start feeling some rain right away? Because it's continuous, right? So is it possible that we may have like a 1/4 inch of rain in 15 minutes? Yes?
Yeah.
Okay, good. So think about that. So let's look back to what I just talked about with the vacuums. Is it possible? Is it possible? Oh, let's talk about this. If he sells 0 vacuums, it's how much money?
0.
If he sells 1 vacuum, it's how much money?
20.
If he sells half a vacuum, how much money?
You can't sell half a vacuum.
Continuous or discrete? Talk to your group and talk to them about why. Go.
Because you can't sell half a vacuum, you can't sell vacuums at half. So it's not always going to be a constant amount. You know what I mean?
No one goes like, I want to go right half the vacuum.
Okay, continuous or discrete? Why?
Because it's not always going to be,
Is it possible to sell half vacuums?
no, there's not always a certain amount of money you're going to make every one or half.
Good, okay. So, we can't, it's discrete, right? So we're all saying discrete. So do we draw a line through this?
No.
No, because if we did, look what happens if I draw a line. It's like us saying that, oh, if this person sold 5.5 vacuums, he should have how much money? $110. Can they sell 5.5 vacuums? No, people aren't going to buy a half a vacuum. Does that make sense? So do we draw a line through this? No, because it's not continuous. It is discrete. So we're not going to draw a line. So if you drew a line, please take it out. Okay? And you should write discrete, okay? Okay, now with your group, Wow, we're out of time. Okay, almost out of time. With your group, domain and range. Ready? Go. Domain and range. How far left and right, and how far up and down? Okay. Domain and range. What's our domain?
0 less than x through 10.
Okay. And our range is going to be 0 to 100. Now I put these in red. Let's say this person, is it possible for this person to sell more than 10 vacuums? Yeah. Like theoretically?
Yeah.
What's the limit in their whole life? So in red it would be up to infinity if it's their whole life. But these purple ones would be the answer here, okay? Okay, that's it. So tonight, that concludes the lesson. Here's the homework for tonight. Let me get you there. Homework for tonight is the following. Page 92 through 93, numbers 1 through 8.